This is Tim Reinbott. I'm the Director of Field Operations and Communications, as well as the Assistant Director of Natural Resources at the University of Missouri. We're back with Dr. Kevin Bradley, our State Weed Science Specialist. We're going to talk about some alternative methods of weed control and spraying herbicides. Now, talk about spraying herbicides. Drones are all the rage right now, and we've used them for fungicides, cover crops, herbicides. So, Kevin, what's your take on this?
Herbicides and fungicides are way different in the way we need to set these up and how effective they will be and everything. So we've worked with Dr. Mandy Bish on collaborative projects, and so let's just start with the fungicides. Makes total sense, okay? Whether, especially corn, we pretty much typically spray a lot of our corn with fungicides already in airplanes or copters. Our research shows fungicides can be applied in the same manner through drones, and they may provide more coverage of the fungicide, and as a result, we've seen a little better weed control in some locations. So we've done 2 years of work. We have a third year plan. These are large, I think these are large strips. We're comparing airplane applications to drone applications. So
Of fungicides.
Late season in corn, fungicide applications. And bottom line, our results are the drone is as good as an airplane, and in some cases could be better because you get a little more coverage in certain situations with drones. So that's a lot of work just to sum up with a sentence, but that's basically what we found.
But is that updraft? Does the drone make much of an updraft that gets the fungicide into the canopy?
Yeah, there's some prop wash there, and this technology is changing all. Like, there's some new drones, which we might get one to work with this year, but the claim, the J150 is what it's called. The claim is this drone is going so fast that you no longer have prop wash. It's like the particles are like they're coming out of a plane. The applications are being made with these at like 35 miles an hour.
Oh, my goodness.
Yeah, so if that's true, which I don't know if it is, but if that's true, then we're moving into a whole new era of drone applications. And that's one of the things we found with drones is the technology is changing so quickly, it's hard to keep up with it. Everything we learn, by the time we learn it, then something new has come out, and it's a whole different thing. But, yeah, obviously the limitation on drones overall is tank capacity. The reason it makes more sense with fungicides is we were already spraying at 2 or 3 gallons per acre, and in airplanes, and in drone, we're still spraying at 2 or 3 gallons per acre. Yes, you might have to fill up more than an airplane, but it's not much different. So that's the status on drones with fungicides.
You said crop wash. What's that?
Prop wash.
Prop wash.
Pushing it down.
Okay.
in the canopy. Yeah.
Which it could be a good thing, though. Isn't it?
Yeah, exactly. It probably is.
But if we're going so fast, we're not getting it then?
Right. It changes the whole dynamics of the droplets being deposited.
Okay.
Yeah. Then moving on to cover crops, again, I think, sure, why not? It makes total sense. It's a calibration thing, just like with any spreader. If you don't take the time to calibrate that right, make sure you're putting out exactly what you say you're putting out, and your swath width and everything else. There's some parameters there that if you aren't careful with your application, you can mess up. But once you figure out those parameters, you can spread cover crop seed over standing crops like corn and soybean, just like you could with an airplane, and it'll do a good job. So again, limitation is just simply tank size and having to refill up all the time. But then we get to herbicides. We don't spray too many herbicides at 2 or 3 gallons per acre in row crops. It's a big adjustment. And we have found that if you're even going to as much as 5 gallons per acre, you're probably not getting the weed control that you get out of a traditional ground rig. And so the real question, again, it comes back to the limitation of tanks and things like that. But our results and a lot of people's results is, I mean, we can do a lot of things and make them work okay, but there's much more variability in the level of weed control with a drone, because I think it's just so much lower of a dose of gallonage that's getting sprayed, and we're just not used to that. So, some of our post-emerge herbicides need some good gallons.
20.
Yeah. And then if you were to try a pre-emergence herbicide and you're only spraying 5 gallons over the acre, and you want pre-emergence residual herbicides to have coverage and so that it inhibits the germination, that's asking a whole lot. So it works surprisingly well for weed control, and I think targeted spraying is where we're going with drones and weed control right now until we get some bigger tanks or bigger gallonages. It's a great idea to be able to go just to an area and spray whatever you want. But it's just that limitation on the tanks right now.
Okay. Now, airplanes, herbicides with them would be the same issue, wouldn't it? 2 or 3 gallons per
They
acre?
spray lower doses, but again, that depends on the crop and the area and the geography and what the herbicides getting sprayed. But like I said, things are changing so quick with this possibility that a drone application is more like an airplane application. That changes things altogether. We've found that with drones and herbicides, the percentage of fine droplets that are generated is way higher, and there's not much you can do about that. And so fines are those that drift off, and so the likelihood of drift is higher, so that's a huge consideration.
So if you had 2,4-D type,
it's
hormonal could be terrible then.
Yeah.
Now, height from the canopy is important. I saw some of your data. 5 foot versus 1 foot versus 10 makes a big difference, doesn't it?
Yeah. So that's the thing. All of this, the parameters are being dialed in. 5 is fine. We found 10 might be better in certain situations. So again, it's almost like you have to match the research with the particular model of drone, and there's just a lot of moving parts there. But it is a very active area of research by a lot of people throughout the country right now.
And nozzles.
Yeah,
that's pretty simple on the drones.
They do not have traditional nozzles, which I would rather see that disappear. So they have these very different nozzles that are the reason for the fines. And I understand why they have the nozzles that they do. That there's a greater, with such low gallonages and higher percentage of active ingredient, there's a greater likelihood of clogging with our old traditional type nozzles. I think the weed science message to the drone industry is we'd like to see a fixed boom with a traditional nozzle as more of an option in the future, and we'll see where we're going with all of this. There's some crazy things that are there's fixed wing drones being talked about, like military looking things that would be more like basically just flying an airplane over.
Sure.
Yeah.
But a fixed boom with 2 or 3 nozzles on it.
Yeah.
Because right now they only have one.
Right. It's 1 or 2 depending on the model, and those 1 or 2 are giving you a 25 to 30 foot swath width. So yeah.
That's a lot.
Yeah.
That is a lot.
Yeah.
Because I've seen your weed control data. It really makes a difference.
Yeah. You'll see differences among the swath width, and that's what we don't want, right? Like, you go out there with a commercial ground rig, these things are $750,000. They, 80 years worth of research going into making those work right. And you see the same level of weed control across the whole swath width, and you see the same pattern of spray deposition across the whole swath width. And then we have a strip and compare that right side by side with what you get out of the drone, and it's like peaks and valleys and weed control and spray deposition. So there is more variability there.
Okay. The other one that you've done a lot of work on is electrocution.
Yep.
And that has its place also.
Yeah. I like electrocution because we're still figuring it out, and we still don't have all the answers. We're going to, I think, be working with some new companies next year on electrocution, and I think it has a potential in the future for sure. We've kind of tested proof of concept, and we can kill some of our worst weeds with electrocution. There is variability, which my goal is now to understand the variability and take variability out of the equation for the grower in the future. But my whole thing, Tim, is could we see autonomous robotic units going in between the rows of corn and soybean in the future and zapping a weed to remove it? I think that's where we're testing, okay, what are all the factors that make it work better and what are all the factors that make it work worse? And then you smart engineer people go figure out how to make it do. So I don't really care how we remove weeds in the future. I don't think it's going to be 100% herbicides. I think it might be we detect weeds, we kill them with either targeted tillage, targeted electrocution, targeted flaming. It doesn't really matter. Maybe targeted spraying, but our spraying is getting less and less options. I mean, the more resistance we get. But back to the electrocution thing, yeah, I mean, we've figured out some reasons why we can go to some locations and one day in the summer we get 95 to 100% control of water hemp, and then in another day we get 80%. You know, why is that variation? We found plant moisture influences weed control, so the more droughty a weed it is, the more drier a weed is, the less it's going to get killed. The wetter it is, the moisture it is, the better. We found that placing that boom lower on the plant, the part that actually electrocutes it, is going to result in better weed control. And that has been a significant finding because we need to come up with some better implements that aren't going above the crop canopy and just getting the top 2 or 3 inches. We need to be able to get in between those rows and get down lower on the plant to be more successful. And there's some companies starting to do that. So I think there's possibilities there in the future. I'm not saying it's the be all end all. There is no silver bullet, but there's exciting things to learn still about electrocution.
Yeah, because you could have it GPS tracking and where it can sense where the row is, so it'll have a electric, in between the rows.
Yeah, there's a lot of possibilities. So there's 3 companies that think enough of it that they're in it. The one we worked with is a Missouri-based company, and that's the weed zapper. But there's another company called Lasco Lightning Weeder, and they're pretty popular. And then there's I believe they're European, Zasso. So they all sound kind of familiar, and it's easy to get them confused. But Zasso is another one. So, but we think we're going to be working with Lasco a little bit this year and doing some more work. So, yeah.
So if a person has a water hemp or Palmer amaranth that's resistant to 3 or 4 different chemistries and it's above its canopy, are there folks that have zappers that can come in and zap your field for you?
We have organic farmers that are doing that for other organic farmers. Mm-hmm. So far, I haven't seen a whole lot of adoption in the conventional, quote unquote, conventional corn and soybean farming community. But that's the idea. I don't think that any of these things are going to be something that farmers go necessarily buy outright. Mm-hmm. I think it's a fee for service kind of thing. You know, if a retailer goes and sprays in July for a farmer to try to clean up escapes, and we have limited success at doing anything in July with a herbicide, why couldn't a retailer go offer electrocution as an option in the late season to try to clean up escapes?
Right. And our organic folks have been using hot water.
Yeah.
Flaming, like you mentioned earlier. So there are other alternatives out there.
We could learn a lot from organic and specialty crop markets, the vegetable growers, high value crops, and the organic world, they've been having to do weed control without herbicides for a while. We can take some lessons from them in our world of fewer and fewer herbicide options available.
Yeah, utilize your cover crops, utilize every tool that you have in the toolbox.
Yeah.
And they can't get resistance to hot water or to flaming or electrocution, hopefully. And then I know you haven't done the research on it, but your colleagues have on See and Spray.
Yep.
There's opportunity there to reduce our herbicide rates.
No question. So the weed world, university non-biased weed results. So let me start with this. You're absolutely right. I have not done any research on See and Spray, primarily because, if I'm not mistaken, one of our biggest retailers in the state, I think we only have one unit in the whole state.
Sure.
But the university research that's been published on it all says what you would hope that you get out of this. I mean, it just varies on the weed density in the fields, but I think one study, they had anywhere from like a 30 to sometimes as much as a 60% reduction in herbicides. You know, the reduction in herbicides is just going to be a reflection of how many weeds are there that it detects and sprays. So the herbicide load on the field is going to be reduced. Okay. They have different sensitivity settings on the See and Spray, and the more, and the bottom line is that works. The less sensitive you make it, the more misses you're going to have. The more sensitive you make it, the fewer misses you're going to have. So they know what they're doing. They've put a lot of money into this, and they can identify weeds and they can target them. The money reduced of the herbicide savings is real, but really where we are, Tim, is, I think I'll just speak frankly, retailers don't have a model yet that works for them economically, because number one, they are the ones that sell the herbicide. If we're going to reduce our herbicide use by 50%, where do I make up that money? And number two, the See and Spray has a subscription-based per acre charge for anybody that's using it. So all of a sudden, the retailer has more cost to go across and spray, and how many growers are going to pay more to get less herbicides? I mean, you really got to be passionate about, so it hasn't figured itself out in the market yet. I believe it will sooner or later. They'll come up with different subscription fees that are more feasible or whatever. There are some, in some other states, there are some big farmers that have just outright bought it and use it. And obviously, if you're a farmer and you can afford that, it's going to save you a lot of money. Okay, so, but the technology works, and I'll tell you who probably likes the idea more than anybody else, the EPA.
Sure.
They love it. It may in the future give us points on herbicide labels and things, like if you do this, you get a certain number of points, and these labels in the future are all going to be about you have to accumulate a certain number of points before you can legally spray the herbicide and everything else. So anyway, I think the EPA loves the idea of reducing that herbicide load. I'm sure we all do. It's just right now it's hard to make the model work financially.
So there's going to be there's a lot of tools left in our toolbox. They'd be a little unconventional, like the See and Spray, the drones, but also the robotics.
Autonomous robotic weed removal is going to be our future, in my opinion. I don't know.
Well, it's mechanical that way, like you mentioned, or even chemical, where they're essentially See and Sprays out in the field.
Yeah. They have it right now. Like I said, I got the opportunity to go view a lot of different future type things. And I hesitate to even say future because they're being used in specialty crops and vegetable crops right now. They're just not maybe suitable for large scale conventional agriculture. But I saw different types of sprayer that there's one called a verdant robotic sprayer, for example. Like it creates a 3D image of weeds as it's going through the field, and has like a turret like on a battleship, and it spins that, and it has like a whole lot of these turrets lined up under this covered spray canopy, and each turret rotates and targets the meristematic regions of the weeds and shoots the herbicide on that part only, and targets the most vulnerable part of the weed. And just phenomenal. That company, that product was co-developed by somebody who worked on NASA. I mean, like, it's crazy the amount of technology that's going into these things. So we have targeted sprayers. We have targeted weed removal of all kinds.
Well, it's exciting because we'll probably it'll be on top of us before we know it that, wow, we've had a major shift in how we do it.
Yeah,
because I've seen this with GPS, auto steering and all. It seems futuristic, and all of a sudden it's there.
Yeah, exactly.
As we wind down, you mentioned to me a month or so ago about living cover crops, because that's another thing down the road that we could use for weed control. Just that competition.
Yeah. So you've been doing some of that. There's some other people. We haven't done a whole lot of it. We're doing a little bit of it this year from the standpoint of, if we have autonomous robotic mowers, which go between rows and can mow things, which we do. Greenfield Robotics is one that comes to mind. They do what I just said. What if we had living cover crops between the rows that got mowed on a regular basis, in between soybeans or corn or whatever? It's some things we got to figure out there, but I think that is also a part of our future, is having this idea of living cover crops, and maybe we have robots that are worked in conjunction with the living cover crops in some way. So
yeah, that gives us a lot of our other advantages on soil health, water infiltration. In a livestock situation, you could use it, graze it early or late, or so there's lots of opportunities that way. And one thing, I've been to some conferences, and I keep hearing about one of the weeds as a cover crop that you call weeds, annual rye.
Yeah. Well, ryegrass.
Ryegrass. I don't. Yep. Sorry about that. Is there still those issues that we have?
Ryegrass, some people call it annual ryegrass, some people call it Italian ryegrass, and some people get really upset about which one you call it based on the cover crop and everything else. It's Lolium. It used to be multiflorum. Now it's Lolium perenne, subspecies multiflorum. So I don't really care what you call it, but that's the genus species that I'm talking about. Unfortunately, the biggest weed problem in Kentucky and Tennessee, in that western Kentucky and western Tennessee geography, and some parts of eastern Arkansas right now, ryegrass has eclipsed Palmer amaranth as their biggest weed problem. That's coming directly from the mouth of my colleagues who have the same job as I do in those states. Larry Steckel at Tennessee, Travis Licklider at Kentucky.
Oh, those are Missouri guys.
Yeah.
Missouri trained people.
They are, yeah.
Oh, wow. So, and that came more from the forage side, you think? Using it as a forage?
I don't know where it came from, but, we have it as a little bit of a weed problem in Missouri. Nothing dramatic yet. I grew up in Virginia, Eastern Virginia, and ryegrass and wheat it was a horrible problem. So it could have been small grains, it could have been forages. I don't know where this is coming from, but boy, they can't kill it.
But if you do use it as a cover crop, you do not want it to go to reproduction. You got to terminate it early.
Yeah, and it just requires more management as a cover crop. But when it sets seed, there's some percentage of that seed is not going to germinate the year after. It's going to germinate 2 or 3 years after. And
the hard seed, that's the issue.
Yeah.
Oh, shoot. Okay. Kind of like hairy vetch.
Yep. Yeah.
All right. Well, thanks, Kevin. This has been a lot to think about, and it's exciting. That the future is exciting.
It is.
It really is.
It is.
Maybe you'll be around long enough to see it all.
That is a question mark.
That's right. All right. Well, thanks, Kevin. And this is it for Tim's Take.